Hi and welcome to Vulcan-CFD tutorial number 4. Here I'm going to primarily focus on scripting of Vulcan-CFD, but I'm also going to cover the differences between local time stepping and a fixed delta T time stepping. Like bash, the TCSH shell commands can be used to make a script file, and these scripts provide a number of interesting possibilities for Vulkan. However, I've primarily been using them for queuing jobs for a single machine. There are 3 steps to make a TCSH script file. First, you have to write the script file. Second, you have to change the permissions to include execute. And third, you need to run the script file. Throughout the rest of this tutorial, I'm going to walk you through an example script file that I've listed here. This first line is similar to how you create a bash script file. And this tells Ubuntu that the TCSH shell will be used to execute the following commands. For this example, I have 3 very similar problems set up in 3 different folders. And I have created a for loop here that will iterate through each of these 3 folders and execute the exact same commands in each folder. An example used for this, and this is what I'm doing in this example, is that I have 3 different folders containing very similar problems with slight changes in the boundary conditions. And this will allow me to iterate through each of these folders. First, I change the directory into the first folder. Next, I output the current directory and the timestamp. In the next several lines, I run both the local time stepping method and a time stepping method for the same problem. The time stepping method actually takes the solution from the local time stepping method as its input. And next I have the time history results from the time stepping method merged into a single file for each time step. And of course, because this is a for loop, it'll then iterate through the other 2 folders. There's a neat program called Send Email in the Ubuntu App Manager, and it sends emails from the command line, and this allows me to email myself or have the computer email me when the computations have finished. Next, I'm going to show you the 3 folders I have set up with the 3 problems. First, let me show you the script file again. If you remember, the second step to the script file is that you have to make it executable. So let's add those permissions. I'm not going to execute it just yet, but here's the command again. If you recall, Vulkan comes with a program called timeMerge, which will merge the time history files for each time step when you're doing a fixed time stepping method. You can make timeMerge a script by adding the following file as an input to your timeMerge command back in the script file. And finally, I'm using the same hostNames file for all 3 problems. Inside of each of these folders, I've included 2 input files, one for the local time stepping method and one for the time merging method, and also the grid file. The local time stepping method can be used with an auto CFL number feature, where it detects stability and changes the CFL number accordingly. This is great when you're trying to achieve a steady state, but you don't know what CFL number to use. Part of the reason why the local stepping method is faster is that it doesn't use the same CFL number for each cell in the grid. The downside to this is that if you want to output the time history, it just can't do it because the time's not fixed across the grid at any given point. Therefore, if you want to see the solution as it evolves, or you maybe have a quasi-steady state instead of a more traditional steady state, then the time stepping method would be better. The example I'm showing here is a good way to use the local time stepping method to rapidly approach something close to the quasi steady state solution. and then use the fixed time stepping method to achieve the true quasi-steady state, as well as view the output time history files. Here I've specified the time stepping method to be the local time stepping method. To do a variable CFL approach with a minimum of 0.00001 and a maximum of 1, and to not load the restart file. Here the restart file that I am writing out is called restart.rst, and it writes it every 5,000 iterations. And this is important because the time stepping file, which we're going to go through next, is going to load this file when it starts. And you'll notice that they're both using the same grid file. The time stepping file here is similar, except that we're using a delta t, or a fixed time stepping method, instead of the local time stepping. Even though the variable CFL number is set to yes here, it won't do it because it's using a delta t time stepping method. We are reading our restart file, and the time steps are fixed to 2 times 10 to the negative 6 seconds. The key to pass the solution from the local time stepping method to the fixed time stepping method is that they both are using the same restart file names. And finally, let's run the script. This is going to take a bit, so I'm going to fast forward. You can see here that it's finished the first folder. While it's processing the next two, let's take a look at the first. Here you can see that the time history files have been both output and merged. And the two other folders are still being processed. Let's do a little more fast forwarding. And it has finished and sent me an email. Thanks for watching, guys.